So I'll just start by saying thank you to everyone for joining us today. I'm Molly, I'm a marketing associate with the Passivhaus Trust, and I'm really pleased to welcome you here today in the first of our Passivhaus Retrofit case study lunch and learn series. This is the first in our series, as I say, and so thank you for joining us from the start. We do have several more of these sessions live on our website, which I'll talk about at the end. So this series has been developed in response to some really great interest that we've had in retrofit, particularly following the Guy Martin documentary that was broadcast last week on Channel 4, The House Without Bills. If you haven't seen it yet, it is available to watch online. I would highly recommend that you do watch it. It's a really inspiring story, and we've got loads of other inspiring case studies, of course, one of which we'll be talking about today. So today I'm delighted, thank you, to be joined by Alan Budden of Eco Design Consultants, and he's going to be presenting the Kinver project, which is a whole house retrofit of a Victorian terrace property in Oxford, and also by Guy Hargreaves, who is the homeowner. The presentation should last around 25 minutes, and then we've got plenty of time following that for Q&A. So just a quick note from me on how the session will run. This session is particularly aimed at homeowners, including those who may be at quite an early stage of their retrofit journey. So please don't worry if some of this technology is quite new. So as well as homeowners, obviously, we are pleased to welcome architects, designers and other professionals today. And so these sessions are designed to be useful for a mixed audience. We are recording this session, and we will be moving after the presentation. We'll be moving into a Q&A. So please do use the Q&A function to ask your questions. If you ask them throughout the presentation, then you can also upvote questions that you particularly are interested in as well, and that just will really help us to prioritize which questions to cover. So that's it from me. If I can hand over to Alan and to Guy, and again, thank you for joining us, and I hope you enjoyed the presentation. Thank you.
Thank you, everyone. Hopefully you can see the screen now. So I'm Alan Budden from Eco Design Consultants. I'm an architect and a Passivhaus designer. I've been a Passivhaus designer now for about 18 years. So I've been doing lots of these sort of things and very involved with the retrofit of existing houses. These are a selection of some of our projects. So many years ago, we did our first Passivhaus that ended up being the most airtight Passivhaus in the UK, with an airtightness of 0.06, so an extra zero in it. We've done various other new build Passivhouses, including Passivhaus Plus, which has lots of renewables, giving real zero bills, like the TV show. A number of other houses, some houses we've retrofitted to full Passivhaus and some to the slightly lower Enefit standard, which is the Passivhaus Retrofit standard, including my own house here, which I'm talking to you from at the moment, which is the top right-hand corner, which I'm slowly retrofitting down to the Enefit standard. Not quite there yet, but I'm not far off, but it's still a fantastically comfortable and nice house. Okay, so I didn't want to go too much into sort of some of the technical stuff, but there's a little bit here, just some of the main criteria behind Passivhaus, because Passivhaus really is building physics. It's all about real science and physics. There's nothing particularly magic about it. It's just making sure you do all the good building physics stuff and you get a fantastic result from it. What's interesting, I think, about the whole standard is a lot of it isn't just about energy and energy savings and carbon reductions. It's actually about comfort. So on this slide here, you can see some of the elements and the criteria, both of the Passivhaus and the Enefit, which is the Passivhaus Retrofit standard, and whether it's related to comfort or energy. So airtightness, which is probably one of the most important and difficult ones to achieve. Passivhaus having an air change rate of 0.6 air changes per hour, and Enefit at 1. That is also very important in terms of comfort as well as energy. The next one down, which is one that's not often talked about, but it's really important. It's about internal surface temperatures. I'll talk a little bit more about that a little bit later when we talk about windows. Basically, what we're talking about there is making sure that all surfaces are above 17 degrees. This means that you're going to be comfortable. You won't feel any drafts coming from cold surfaces, and you won't get any condensation and mold. Also, some overheating, good ventilation through mechanical ventilation heat recovery, a low heating demand, a low overall primary energy as well. So those are various things, but often it's more comfort related. So basically the criteria: low heating demand, high surface temperatures, airtight, mechanical ventilation, overheating limit for summer as well. That makes sure you don't get any of the cold condensation and mold, no external pollutants, and any internal pollutants there are will be removed, resulting in warm, comfortable, healthy buildings, which is just fantastic. The alternatives you might look at would be, if you're trying to reduce carbon, you might be tempted just to go for a really fantastic heat pump and lots of PV and not worry too much about the fabric of the building, in which case you could get a low carbon and be very good for that, but you aren't necessarily going to address some of the qualities of the build in terms of healthy internal environments and reducing the demand down. So basic design principles. So designing a passive house, what people usually think of first is the insulation. So that's your duvet of insulation around the house. Having good windows. So we'll recommend triple glazed windows. And again, I'll talk a little bit more about this as we go through. But that basically, for a passive house or the end of it, needs to be triple glazing. And the reason for that is that surface temperature. It's the only way you can guarantee your surface temperature above 17 degrees. A good ventilation system to make sure you've got nice quality air and you're trying to retain as much of that heat in the ventilation as possible, so you're not losing all that nice warm air out the window. Air tightness, really important, making sure that you're not having any heat loss through the drafts. But also, this means that the quality inside is much better, so there's less drafts, better control of humidity and other things. Thermal bridging, this is one that's often misunderstood and not very well understood, and particularly important in terms of your retrofits. So this is where you've got elements of the building that might transmit heat from the inside to the outside through what's called a thermal bridge, which is kind of like if you have a concrete beam or a steel beam that runs from the inside of the building to the outside. Heat will just go straight through that bridge from the inside to the outside, and that will have two things. One, it will lose lots of heat and energy. The second thing is, it also means that surface temperature inside is going to be very low. So if you had maybe a 1960s house with a concrete beam above your windows that is also expressed on the outside, you'll probably know that's the case because you'll have a nice moldy patch above your window where that concrete lintel just spans between the two, and that heat is basically being transferred straight out, so you've got a cold surface. So reducing thermal bridges is really quite important and important to go through. Some other principles that you may not be able to do quite as much with if you're doing a retrofit to the new build would be things like the form factor, which is the shape of the building. Basically, it's the shape of the building that loses heat. So it's the surface area that's losing heat. So the more compact the building is, the less surface area, the less heat loss. You can do a few things with it, but usually it's fairly limited with the existing building. And orientation. So ideally, you'd face your building, the rear of the building to face south, not only just for solar gains, but also for keeping it cool in summer. But with an existing building, you probably can't do that. So retrofit, really, really important. People might know this already. Ideally, by 2050, we're all going to be zero carbon. But all the buildings now are going to still be around. 80% of the buildings now are going to be still around in 2050. So we need to do something about the existing buildings as well as the new builds. In terms of performance, this is one of the things I really love about Passive House and why I'm such a great fan of it. You look at, this is a study done by the Leeds Metropolitan University, basically checking between what was predicted through the energy calculations and what was actually measured in these buildings. So there's a whole large sample of buildings split down into types. And you can see here the red is the measured and the blue is predicted. Worryingly, on average, the buildings are 2/3 worse than they are measured in terms of predicted. But at the bottom corner, you can see the Passive House ones really much closer to the predicted, and also much, much lower as well in terms of overall energy use. So what's shown time and time again is that the Passive House methodology does what it says. And more recent studies by Oxford Brookes has also come out with similar findings to say that Passive House, in terms of the calculations, is much more reliable than some of the other energy calculations. So that's why we love the Passivhaus. So a big question people often ask me in terms of retrofits is how far should we go? Should I just do a shallow retrofit or should we do a deep retrofit? So a shallow retrofit is when you might just do a bit of extra loft insulation, little bits here and there, basically. It can be good in terms of getting your carbon reduction down, but it has limited benefits to the health. Like I said before, it's about trying to get the surface temperatures up and stuff like that, but it just won't do unless you go for the more deep retrofit. Also, in terms of deep retrofits, you get much better in terms of a community, in terms of reducing power loads in different times of day and between summer and winter. So it's much better in terms of the country overall if we went for deep retrofits, but I won't go too much into that now, to be honest. We can talk later in the questions. So for me, what's really important is, first of all, having a whole retrofit plan, but then maybe phasing it. So for me, like in my house here, I couldn't afford to do the full retrofit, deep retrofit in one go. So the options were either a shallow retrofit and being locked in, or going for a deep retrofit and doing in stages. And that meant that I could keep going and doing stuff. So it's much better in my mind to do one item well and not have any regrets. So for instance, if you're doing external wall insulation, putting on the full 200, 250 millimeter installations now, rather than going for 60 millimeters, because that's the most economic and you can afford at the time. Because then if you want to do it later, you're going to have to redo all the render and all the rest of it, which is, to be honest, the majority of the cost. The actual cost of going from 60 mil to 250 mil isn't that much. It's mostly involved with the material costs. So it's not a huge step up from that lower level. So it's much better to do each individual item well than lots of separate bits to a lower standard. So going into the whole house plan, and I will go into some project stuff very soon, you'll be pleased to know. So if you look at our process, you can download this from our website. And also, if anybody does want a copy of these slides, more than willing to share it for you. At the top of these slides, I've got an email address, design@edc.eco. If you email us on that, we can send you a PDF copy of the slides so you can have a look later in case you want to learn some more. So the project started off in Oxford, so the Kinver Passivhaus. So Guy, who's online at the moment, he'll talk a bit later. Guy and his wife Susan, they have a Victorian mid-terrace house, and it was in need of modernisation. They also came to us with an extension already planned and got planning permission, but they're looking for it to be comfortable and eco-friendly. So we talked to them. So this is about developing the brief, really understanding what they want to do. The next step is helping define the goals. And for us, we've got a survey where we try and get people to score things out of 10 for various elements, particularly around the eco stuff. So whether it's about reducing your carbon, whether it's about health and comfort, whether it's about reducing your fuel bills. So what those things are make a difference in terms of what we choose in terms of insulation materials and so forth. Once we've done all the sort of the brief stuff and we've done any design work, we then may look at the energy stuff. So this is the PHPP, basically the Passive House Planning Package, which is where we do all the energy calculations. It's basically a huge Excel spreadsheet, which is kind of open source, so you can see how things are working. You can see a couple of spreadsheets behind there. We've taken that and we've adjusted it slightly so we can do some extra macros and we can run some reports to show how so if you increase your external wall insulation, what effects that will have on the overall building. We do various graphs, other bits and pieces as well. So the analysis through the PHP is really important to try and understand what you're doing. So Guy's and Susan's house. So we gained planning permission and we provided a comfortable and healthy house with low bills. So a quick video now, hopefully this will work. So this is Guy's house as it was originally from the outside, and inside you can see fairly standard. They moved in just over Christmas, you could tell, and the back garden slightly overgrown. So a fairly standard terrace house. So we pulled down the rear extension, which wasn't very good. One of the reasons for doing that was to fill up that silly gap between the extension and the neighbour's house, so that was losing heat and getting space down, and was one of the changes we did from the original architect's drawings. So the foundations are going in there, the rear, Some structural beams we moved up, particularly in the basement where the ground floor was quite low. So moving the beams up was helpful. Stripped out the house completely. You can see there all the brickwork back to original. Some of it, including that front bay, wasn't particularly great. Here you can see some of the insulation going in for the floor of the extension, the roof being amended, and the extension going on. So at the front, you can see there the bay window had to be completely rebuilt because once we opened it, stripped it back, it just wasn't structurally safe. So it ended up being rebuilt. Small extension on the back, some insulation going into the roof. So slightly different strategies for the front roof to the back roof because we need to keep the insulation level at the front and at the back. On the walls, inside the front walls, we used a combination of lime and cork render, wood fibre and a lime plaster. Ventilation going in, some air tightness tapes. So the rear, you can see a green air tightness board there at the back and lots of air tightness tapes. The windows being replaced. So these going into lovely new triple glazed windows. You can see them going in there. So though they look like sliding sashes, they're actually open at the top, but look fantastic. And you can see the windows there in place and the wood fibre insulation going in. At the rear, at the back, we had a large glazed window that had to be craned in. You can see it, sort of saw that going in. So this is the top floor bedroom looking out the back, finished kitchen, finished living space, which we opened up through to give a lovely space and a view out the rear extension from the dining space into the back garden. That's a quick whistle stop tour. Okay, so just moving on to some of those points in detail. So we've often talk about Passivhaus as 5 principles. So here I've got 8 principles. So I'm going to quickly go through what we did to explain what we did on each of the projects. So number 1, the insulation. So you can see here the rear extension, which was a timber frame with mineral fibre insulation going in between the studs. So it's a big insulation over your house. Not necessarily as much as people think to the Passivhaus standards. So if you're doing a new build, it might only be a little bit more than current building regulations. But compared to an existing house with no insulation, obviously quite a lot of insulation going in. To me, it's important about what insulation you pick. And there's a whole topic that I'll talk about in terms of what insulation goes where. But you want to make sure a couple of things. One, it's continuous. You don't want gaps. Often we think that soft insulation is easier because it means that it can squash into those gaps, as you can see there. And it's really important to make sure you get what you're asking for because you need to check the thermal conductivity or the lambda value to make sure it's the type of insulation that you want to use and you aren't getting something less performing. The second thing is efficient shape. So it's very important that you look at what I called earlier, the form factor. So just a quick example there, we've got a mid-floor flat and a bungalow. So if you opened up those buildings and you showed what the heat loss area was, the bungalow there has 279 meters squared of heat loss area. And the flat, because it doesn't lose heat to the flat below and the flat above or to the communal space, has only got 74 meters squared of heat loss area. And both of those properties built to current building regulations, same U values, same everything else. The mid-floor apartment is 2,000 kilowatts to heat. The bungalow, 4,500 kilowatts to heat. The only difference is the shape of the building. You can see clearly that bungalow is over double the amount of heat required in the bungalow. So making your building as compact as possible really does help in terms of reducing your fuel bills. So on some buildings on Guy's project, so you can see here, this is the new rear extension that was rebuilt and extended at the back. One of the things we did, which you could see briefly in the video, was we built it right up against the neighbours. So we used the party wall. We didn't leave what I often think of as a silly little gap between your extension and your neighbour's extension, which will just fill up with leaves and cause damp problems and other stuff, but also hugely leaking in terms of moisture and other things into there as well, and heat. So that was one of the large changes that we could do to make it more efficient. Often other things we do is things like the location of the front door. If it was recessed, this one is recessed, but we felt it was undesirable to move it to the front surface because of the aesthetics. Often we would move that front door, the thermal envelope, right to the face of the building to reduce those losses. Second item here is the thermal bridges, which I spoke about briefly in terms of those the steel things. So to me, some of you in the audience might remember the old sleeping bags with a metal zip, which was horrible. To me, that's a thermal. Well, that is a thermal bridge. So now with plastic zips, that helps reduce that thermal bridge. So it houses, those thermal bridges can be all over the place. So typically insulation is soft and squidgy and not so good in terms of structure. So typical difficult areas are things like around the foundations, around the roof, areas where you need structure as well as insulation, and just try and keep that continuous insulation. Some examples of this. This is some work we did in terms of some thermal bridge calculations, just to try and explain how important this really is. So if we take, this is a typical section through a window. So the darker orange here is the brickwork and blockwork of the existing 1980s cavity wall. The yellow, the cavity wall insulation that's been put in. The green, the window frame sort of cut through. And the orange here is some external wall insulation. So if we left the window where it is, the heat will just transfer straight around to the outside. And you'll get a nice cold surface on the inside that's probably going to get mold on it. So we worked out what the losses from that window if we kept it where it was. And basically, it's the equivalent of not bothering with the external wall insulation for this area here. So 6.34 meters squared around that window. So it's a huge area of losses compared to if you did move it out. So if you moved it out into the insulation, reducing that thermal bridge and reducing the sort of the surface area of the building, that then reduces down to 0.34 meters squared. So you can see a huge difference in terms of energy losses. But to be honest, to me, what's much better is that internal surface temperature. So there's the reduction in terms of risk of mold and condensation and discomfort really from the inside. So these sort of details really make a huge difference in your retrofit and are really important. These are some of the examples of what we did within Guy's house. So lots of it's where the steel was. So some complicated details that needed detailing. You can see here the windows with the wood fiber insulation going on, wrapping over the frame to making sure that the insulation and the window frames really do join up. So point number 4, drafts. So this is about your air tightness. This is about making sure your building is airtight. But one of the important things to remember here is moisture movement. And moisture is really one of the enemies within your building, and particularly with the retrofits that you need to be careful how this works. So getting this to work is really, to me, it's a bit like comparing the old cagoule with the new Gore-Tex coat. So the old cagoule, you go out walking and you'll be really sweaty and damp inside your cagoule. If, however, you now have a nice Gore-Tex coat, it will let moisture through. So this is where water vapor is a smaller molecule, and that will be able to go through small holes, whereas air and heat is then trapped inside, which is a bigger molecule, won't get through. So a lot of that sort of membranes and other building materials are vapor open. So that allows water vapor through, but it is also airtight. So it doesn't mean that heat and air can't go through. So some of those, some nice clever membranes and stuff we use now. There's also things like lime plasters and other things, a lot of the natural materials which are actually vapor open and also airtight. So it's not necessarily using plastics and other things like that. So we do need to be really careful about the materials we use in terms of how moisture moves backwards and forwards through the construction. And that's something that I think I really need to stress in terms of what you're trying to do in the retrofit. Particularly, I would discourage people using things like insulated plasterboard on the inside, which is vapor closed, which won't allow that moisture through in the way it needs to move between inside and outside in different times of year. Sorry, I'll get off that soapbox now and move on to back onto the air tightness. So here, what I've done is we've got the losses and gains from a typical passive house, and this is that Guy's house, where we've got all the losses on one side, so the windows, the roof, the floor, and ventilation and drafts, infiltration. And then we've got some gains, so some solar gains, some internal gains, and then the heating demand. So heating demand here is 14 kilowatts. So if we then change that, so we change the drafts, the infiltration, from 0.6 to 10, that heating demand then goes from 14 to 66. So a huge amount of difference in terms of heat losses. So it is staggering how much difference it makes. Also, to be honest, by being airtight, it means that the warm, moist air that's leaving the house through those holes, basically has got can condense and cause condensation, mold, rot, all sorts of things. So by having it airtight, those sort of risks are greatly reduced. So you've got a much better longer term house as well as the other things. So in Guy's house, we used all sorts of different techniques. So we had airtightness layers moving from inside to outside in different places. So this is part of the extension roof with the membrane, airtightness membrane underneath the roof and over the roof. So it's having to lap round. So lots of very clever airtightness tapes and membranes to make sure it all works. We have, in other areas, we used paint-on breathable membranes. So this is the purple passive, which is painted around the joists. And here you can see some of the other membranes and tapes. So this is one that you can plaster onto. So this is where the membrane was then taped to the wall. And then that allowed us with the lime plasters to be taped onto it and make sure we've got a continuous airtightness layer. So it's really important to use the right materials in the right places and think through the strategy. So once you've done that, you basically need to test it. So this is a blower door, which I think on the TV show that was also shown. So pressurizes and depressurizes the house to allow you to measure the pressure differences to see how much is lost. Also, what's really important with any of these projects, either new build or a retrofit, is to try and do your pressure test before you finish off too much. So here you can see the rear extension. You can see the airtightness membranes and the tapes around the building. And so what it meant is that when we do the test, we can go round and we can find holes. And if you find a hole, we can tape it up and put it right. And we can keep doing that till we get down to the level we need to. So once you've got a nice airtight building, it's really important to make sure you've got good quality air. Because obviously, if it's an airtight building, you will breathe out and that will carbon dioxide will come out of your mouth and you'll build up carbon dioxide in the building, which can be dangerous after a long time, but only a very small amount. And it's days before it becomes really dangerous, even in the most airtight building, but we won't go into that particularly. So you need to have what's called mechanical ventilation with heat recovery. So on the right here, we can see Guy's MVHR, the Zender Q350, which is positioned in his laundry on the first floor. So typically what that does is it brings in fresh air from the outside, and that is then distributed to the bedrooms and the living spaces. The stale extract air from the wet rooms, the kitchens, bathrooms, and the laundry room here, that is all extracted out, goes through the MVHR to the outside. What happens is the stale air and the fresh air pass next to each other, and about 80 to 90% of that heat is transferred from the stale air to the fresh air. So what that means is the air might be 0 degrees outside and 21 degrees inside. As it goes through the machine, the fresh air coming into the rooms might be up to 1 degree less. So if it's 21 being extracted, it might be 20 degrees being supplied into the rooms, but not the 0 degrees of opening the window. A similar thing works in summer, and it can help either bring in cold air from the outside or use it as a heat exchanger to keep your house cool as well. But I won't go too much into that today. Often people think that putting in rigid ducts around the house is quite difficult. And so there's lots of ways we hide them away. So the hallway here, you might spot is slightly different, and we have a slightly dropped ceiling in the hallway. That's to allow some ducts to come through, and we've got outlets in the above doors on the first floor. So there's a few tricks like that we can do to try and hide away those ventilation pipes, which is often much easier than people think it's going to be in terms of the distribution of those ducts. Tips here: don't put your MVHR in the loft unless it's accessible. Put it on the outside wall because it's basically cold air coming in and out of it. So those ducts want to be as short as possible, and really do make sure you design and commission it well. The design of it is really, really important in terms of sound and other things, and that's where Passivhaus really shines in terms of its requirements and its quality. checks to make sure that that works. Number 6, good windows. So on already spoken about the triple glazed windows. So you can see here, -1 outside, 21 degrees inside with your triple glazing. The surface temperature being 18 on the triple, but only 16 on the double. So you're starting to get kind of 4 degrees difference between room temperature and surface temperature, and that will be detected by the human body. So you can see the air will move from the cold to the warm, and you'll feel it in terms of a draft. So these are the outside of Guy's windows on the front. So you can see they look really traditional. What was really nice was it was replacing the sash boxes, so we could hide it in, so it's slightly bigger frames, in behind the stonework as a traditional window would. And the only difference there is instead of being sliding, because the air tightness on a sliding window is pretty rubbish, it was opening inwards. One of the other nice features that we did with Guy, had a fantastic old Victorian stained glass window in the front door. So we actually reused that and encapsulated that within the triple glazed new front door. You can see in the picture there. Keeping cool, so it is important as well as keeping warm. In summer, the building basically acts like a thermos flask, so it keeps things warm and cold. So one of the things you can do is you can try and use shading. So if your windows are facing south, you can have a shading device that lets in the low winter sun, but shades out the high summer sun if pointing south. But also there's various ventilation and other things we can do. Guy's property was one of the things that we spoke about a lot, and we can probably talk with him in a little while about this, but we always knew that this top windows on the top floor facing south for the view was going to be a bit of a risk in terms of overheating. And so we did put a little bit of cooling in to counter that. And it's one of those things that we had lots and lots of discussions around how to keep it cooler. He's Australian as well, so he quite likes it warm. So we can talk more about that, but yeah, try not to overglaze if you can. So point number 8, it really comes down to design. I think taking the passive house stuff and the building physics is great, but you also want to make sure the building works functionally. Also look at good lighting, acoustics and views and all the other design things that you need to think about. So try and bring those all together. And I think it is worth thinking about those things and the future. So making it future-proof in terms of accessibility and other things. So maybe go a little bit further than just the standard passive house requirements. So bringing that all together. This is for a new build passive house, but the retrofits are very similar. So you might start off with building regulations around about 85 kilowatt hours per meter squared per year. You add some insulation, so you go a little bit more on the insulation. You make it an efficient shape. You add triple glazing. You make it airtight, because it's a big jump there, getting the air tightness down. You make sure you use efficient ventilation with mechanical ventilation. You get rid of those thermal bridges, and before you know it, you're down at 15 kilowatts and a passive house, and you've got high comfort levels, low energy costs, and really good comfort and well-being. So this is Guy's finished house. The living space that we opened up between, and you can see going through here to the rear kitchen diner, and that's the kitchen diner there, and going back through to the kitchen. Also on his house, he's also got a flat, which I believe he's opening up as B&B. So I'm not sure, Guy, you can say whether you are currently renting out, and if anybody wants to try before they buy, they can come and have a go and stay in it. Nice bathrooms and the rear of the building. So just to kind of summarize there, I think we have, as you can see there, Guy, very comfortable, wearing his shorts in the winter as well as the summer. A really good building, and these are some of his energy results on the bottom. So back in 2020, before he did the works, he was using combined gas and electricity of about 31,000 kilowatt hours a year. And more recently, so the last 3 years, it's been around the 6,000 to 7,000 kilowatts. So basically a 20 to 21% drop in use. But also, I think probably a much more comfortable house than it was previously as well. And maybe Guy can say a few words on that in a minute. Yeah, so a couple more examples of some of our projects. So I think it's now over to some questions.
Thank you, Alan. That was great. Really lovely property as well, and it's amazing to see the transformation. So we have had quite a few questions, so hopefully we'll be able to cover off as many of them as possible in the 15-20 minutes or so that we've got. And the first question was back to that party wall. So what was done on the party walls in terms of air tightness measures?
Okay, so there's two bits there. So on the main party wall, we did make sure that we kept the wet plasters and the bits of air tightness membranes in places. I think on the top floor where it's to the neighbour's loft, we've had some membranes. On the other bit was where we had the rear extension, which originally planned was going to be set off from the wall. So we basically built up to the existing party wall to the existing house. So yeah, it's important to remember with some of those air tightness elements that generally we're also keeping that as the vapor control layer. So that wants to be generally on the warm side, what it does in the UK. So stopping some of that moisture. So it's just, yeah, we stress that enough to really think about air tightness, moisture, and thermal bridges as things that aren't necessarily that obvious when you look at them.
Excellent, thank you. Then a question from Parker, and I guess the answer to this one could be long, may have to be relatively brief. Could you explain the schedule for this project, as in, as an example for passive house retrofits, how long was design versus construction?
Oh, that's an interesting one. Yeah, there is definitely a longer design stage because we're doing a lot more detailing than you typically would do. Like I said, it's really important around those thermal bridges and the air tightness to get all those right, and to get it costed right as well, to make sure those details are there when you go to tender. Other than that, I think the build time isn't that different. The main thing I would really stress, and it was one of the issues we did have with this project, was making sure that you stop at the right point to do your air pressure test. So you don't, once you've got all your air tightness membranes and tapes and stuff in, you've got the windows in, you then pause, get your air pressure test done, because you can put right anything that's wrong at that earlier stage before you go too far. So having that programmed in. On this one, to be honest, it was an issue because we were doing this during lockdown. I think Guy will probably remember some of the issues and discussions we had around air tightness and all sorts of stuff. And unfortunately, because of labour and other things, they did push ahead on some of the bits at the rear much sooner than I would have liked, to be honest. And so we were hoping, which I didn't say earlier, we were hoping, and we designed it to get down to full passive house, which would have been fantastic. Particularly with the internal wall insulation. So the U-rays and everything else were getting to full passive house. Unfortunately, though, we didn't quite get the air tightness. We needed at 0.6, we got to 0.9. So we were able to qualify as the NFIT instead, but we were very close to getting to full passive house.
Yeah, thank you. We've got a few other questions actually just popping in, but one has just popped up that I would just like to promote personally, just because I'm really interested. And it would be great to hear from Guy actually on what your experience was like, what would the benefit, what would you change, that kind of homeowner's lived experience, I think. And I had this as one of my questions as well. So being the host, I've promoted it to the top, if that's okay.
Fair enough. So I think, like all retrofit experiences, they're not. It's they take a lot out of you. I think we were designing it for a year, maybe a year and a half, and then the build was 13 months, and true build was probably closer to 18 months because we moved in and there was still work to be done. Overall, it was a great experience. I lived in Oxford and cycled to the job every day. I think that was absolutely a critical thing to do. I think that the hardest thing about the build was the air tightness. I really felt that you can get insulation installed, you can move beams around, you can rebuild walls, you can do all this stuff, and by and large, as long as you have competent tradespeople, you're not going to have too many problems. But getting the air tightness right, that's kind of like that's one of those sort of that you have to be on that every single day, and it does become very tiring. In the end, we insisted, or we asked politely and our builder agreed to appoint an airtightness champion who it was almost like a compliance function. So, they would sort of spend all their day working on airtightness issues or getting parts of the building airtight. But to the extent that they were uncomfortable about other parts of the building proceeding that might cause problems down the track when you go to do your final testing. That they had more of a direct line into the the contractor owner, if you like, almost, rather than the foreman, because to some extent you're always trying to make sure that people aren't sort of cutting corners or getting things done a little more quickly than they should have and out of order. We aim for 0.6 air tightness, air changes per hour under the pressure door test, and we came in at 0.93. But at that stage, the house was well and truly, finished, and I was not going to be ripping down walls and digging into finishes to try and find that extra little bit. So you sort of it's a test that finds you out. It's like blowing up a balloon with a pinhole in it. It will not hold air. Alan, everything looks frozen. Can anyone still hear me? Yeah, no, never.
Yep, we can.
Yeah, I mean, what would I change? I mean, I think there are probably a few. We have got too much glass, and we would probably do more external shading, but we've left that as an option for the future. And the solar gain can really warm, very small but specific parts of the house up quite quickly if you're not careful. I think that the form and what we've come up with, we're very happy with. There's nothing to change. We had a great, Alan and his team were incredible. And the house is just an absolute pleasure to live in. So, there was a question about what were the driving motives behind it? And, I think I answered that, primarily it was kind of comfort, it was climate, because we wanted to get rid of gas, we wanted to run a very energy efficient house. And it was to some extent ROI, but ROI is a tricky question. We put solar and a battery last year. We finished the job in 2022, just to be clear. And we put solar and battery in last year. And, I'm asked, what's the payback period on the solar and battery? And I think that's a difficult question, because if I said, well, and, what I've invested in that, that'll be returned to me somewhere in the sort of 5 to 7 year area, depending on lots of other factors. But at that point, I have free electricity. So how do you value that? And how do you value a house that has been retrofitted to passive house certification? It's quite possible that the market will put a premium on that. We don't really know. We haven't got many examples of it. And in fact, really, the ROI, can only best be finally understood at sale, really, I think.
I think that's a good point. There's been a couple of questions that have come in on air tightness, actually, and I just wonder whether it's kind of combining all four of them. We've had a question around how you find the holes during the air tightness test, suggestions for how to test air tightness, and then we've also had, who was the air tightness champion? Was it the air tester or provided by the contractor? And I guess maybe combining a few of those things. I guess it sounds, Guy, like you were heavily involved in the air tightness testing as well.
Yeah.
But I guess over to both of you, really, kind of how would you answer those questions around air tightness?
Well, the air tightness champion turned out it was one of the contractor's employees. Just like if you were running a bank, you would have a compliance function that would be be owned by the bank, but it's a different kind of reporting structure, if you like. And their job really was just to, we had plumbers and laborers and brickies and all the trades, and the airtightness person really focused on things like taping membranes, putting membranes up, um, and then periodically we had a sort of an intermediate test. So the picture of the blower test, of the blower door test that was shown in Alan's slides was done, I think, perhaps 2/3 of the way through. And you're not looking for a result that says, oh, well, I'm going to get 1 or 0.5 or whatever it is. You're basically running around with a smoke gun, and watching where the smoke's disappearing to. And yes, you get. I think the result of that might have been an air tightness of like 6 or something. So it wasn't where. I mean, there was plumbing to be done and all sorts of other things that were ongoing, and we did our best to cover all the holes. But the main thing was to get pressure into the building, so we could see where the subtle leaks were. And when we did the final air tightness test, and we got our result 0.94. We had a smoke gun and at one stage, and we were in on the floor I'm on here, and we're standing outside the bathroom, and you could see the smoke going sort of up through the gaps in the sliding doors in the bathroom into the loft, which is above me, and I'm pretty confident it's going out way down the other end of the house, and so you just when you've closed up, it's over really, unless you're just not going to go back, and you're not going to do it. Well, you're certainly not going to do it on your builder's dime. You might do it if you're prepared to open your checkbook and say, okay, well, I'll delay the project another 6 weeks, and we'll rip that wall out, and we'll get this fixed and that fixed. But to me, it's like when you put insulation in, you can see it's in there, and you can see that it's been done reasonably well, and that's it, job done. Plaster the wall up and move on. But the blower test is that really finds you out.
It was interesting actually. There was another question around air tightness for you, Alan, on the just your observation for stepped retrofit projects where the occupier is not fully moving out, what air tightness reductions are generally achievable. And I don't know if you've got anything to add to what Guy was saying around that.
Yeah, no, it's really difficult if you're going to step retrofit in stages, because there's areas that you can't do, but it is important to try and do that. I mean, one of the things I might encourage you to do is to maybe purchase a small blower door. I mean, I've done that to just over £1,000. I got a small blower door that I can run a test. It's not particularly accurate in terms of its readings, but at least it allows me to do small things like close the door, and if it's getting better, that the problem is outside the door and things like that, and you can often feel where the air is coming in. So it's a good way of checking stuff as you go along, really. But it is difficult as if you're doing it in stages, to make sure that works. It's I think extra attention to detail and tapes and junctions and pressing and making sure the tapes are pressed on, and really going overboard. I think I know in my house here I probably have gone overboard, and I think my son particularly thinks I'm a bit. I love doing taping, but because of all those different bits. But it's a real attention to detail, really. And I think again, in the design stage, you can do simple things to try and make it easier. So with a new build, particularly, I mean, you might be able to move saw vent pipes away from corners just to make sure you can get in and tape it. So there's little tricks that you can kind of work on, and there's some fantastic paint on membranes and stuff now that are, and the air tightness boards and stuff that just make things so much easier, but it's still difficult. But again, the other thing I would really stress is making sure the program that the contractor does is trying to leave that time for the air pressure test, so that you allow a day for that testing, and you make sure you keep going to try and make sure it's getting as best as you can get. I'm not trying to going ahead with other things, which is always difficult.
Well, it's interesting. There's another almost connected question here as well, actually, which is, do you have any advice on how to ensure quality control during the build? For example, did you ask workers to take photos of their work, and particularly thinking about needing to kind of have that wider team, and particularly when things like air tightness is so important? Is there some advice there that you've got?
I think if you're a homeowner like Guy, him getting involved and making sure it's all done is great. Sometimes we get our clients are doing the air tightness themselves, so they're really buying into it and doing it and making sure it's done well. So that's a good way of doing it, I think, and helps reduce the cost a little bit. Um, yeah, yeah,
I would add that you know, it's not for not everyone has the flexibility I had to be able to be on site every day with my iPhone. And I took a photo of every single different piece of insulation that came on. I took photos every day of different things, and when it came to certification. It was just a matter of just finding the relevant photos the certification took a little longer, but I think that was more to do with the certifier's personal circumstances at the time than anything else. But that's my suggestion is to literally photo everything that comes on site.
Yeah, and another related question actually, which is, did you have a project manager on the build? And Guy, you said you attended the site every day, and obviously you've just answered some of that with lots of kind of checking. But how were the workers with that? Were they open to your questions and oversight? Did they welcome it?
Um, I, so we had a foreman who was the contractor's foreman. We had no project manager, but I was a building pest,
Yeah,
and but I generally got on with people. I was accused by my family of being too close to the builder or foreman at times and giving him too much of the benefit of the doubt. Um, I had Alan. Alan, you know, had the option of administering a contract on a fortnightly or monthly basis, and I actually chose fortnightly, which wasn't the cheapest thing, but it was a way of getting formal people on site so that we could discuss things that I think were relevant. And then have a third party, being Alan or one of Alan's team who was also running the project. Um, you know, sort of collate and be professional about requiring addressing of issues and that sort of thing. So that's kind of how we worked it.
yeah. Just to add to that, I think it's really important that
sorry.
we work together as a team with the
Yes.
contractor, and it's all to the same goal, and making sure that there's kind of a no blame culture. So if there is someone makes a hole in their tightness, they're up to it, and we fix it.
Yeah.
Mm.
Um, Guy, you do sound incredibly knowledgeable. And one question in here actually as well is whether or not you've had any passive house training yourself. You certainly seem to be more informed than the average person.
Yeah, well, I'm a New Zealander originally. I'll excuse you, Alan, for calling me an Australian.
Sorry.
I'm a New Zealander originally, although I lived in Australia for 20 years, and I studied mechanical engineering, and then I strayed and ended up having a career in banking. So it was almost like coming back to sort of a bit of an early passion of mine. So I didn't have any passive house training, but I had studied, HVAC and material science and all sorts of other relevant areas, fluid dynamics, that sort of thing. Um, you know, 35 years earlier.
Yeah.
And I wouldn't say it all came rushing back, but parts of it did reappear.
Yeah. Oh, okay. Thank you. So, just conscious of time, a couple of questions, things like where windows were from, and we can probably go through some of those more specific questions, kind of round them up and send them out with any
Yeah.
of the material that we've got. I'm just kind of conscious that we are about out of time, and I'm just wondering if there's any of the specific questions or any of the more general questions that we haven't asked. But I guess another important one for you guys, if you had to do it all over again, would you do it, and B, would you do it differently? I think is a really important one for anyone kind of considering following in your footsteps and embarking on this kind of journey.
So, I think if I do another project, it will probably be a new build. I think the retrofit was hard. Retrofitting a mid-terrace, in some respects, was easy in that you didn't have to insulate, the party walls. But on the other hand, getting them airtight was, a lot trickier. I would choose a time where there wasn't a global pandemic. There were just we just to the if you think about where we were, so we had 2020 was the pandemic, and the labor market had become quite short, and not really people. No, I didn't understand that, and we only really got to understand it when we started our build in 2021, and then we had material shortages and all sorts of other tricky things, which got the whole timeline out of whack, both mine and my contractor. So because it was quite a specialized project, I worked with Alan and with other people on things like getting the MVHR together, getting the heat pump together, getting the heat batteries together, arranging the windows. And so I had my own contracts as well as the builder, and I didn't really, probably it was a risk financially. I could have said to the builder, right, here are all these contracts with windows and whatnot, and all that would have happened is that the builder would have tacked 10% onto the cost of those, and then absorbed any time issues, in their own financials. But because I sort of exposed myself a wee bit to my own contractors getting out of time, but because everyone got out of time, we were a bit lucky. We all lost time, if you like.
Yeah.
So, I can't really stress how, important I think it is for your final result to be to have his best chance of getting stuff done in the order that it should be, and on time, because the minute you get behind in one area, that's when, walls start getting closed up in another area, and then your air tightness starts getting riskier and riskier, and that's that, so probably not. I mean, I certainly and we love the result. I mean, we really do love the result.
Good, excellent. Well, thank you everyone for your questions, and thank you, Guy and Alan, for for the presentation, and B, for answering all of those questions. As I said at the start, this session is part of a wider series of passive house retrofit case studies that we've got. We've got another session on Thursday, but the whole program, which we are adding to almost daily, I would like to say. I think there's 5 sessions in the collection now. We've got a further couple that have been confirmed today. So I would absolutely urge you, please, to join future sessions. Also, if you are an industry professional, please invite your clients to come along to future sessions. I'd hope that you have all found this really useful, having the opportunity to talk particularly to an expert and to a homeowner at the same time, which is really great. We have all sorts of resources available on Passive House website. So yeah, the QR code there will lead you to talk to an expert, some FAQs, the Learning Hub, and of course the retrofit case studies. As I've said, there are several different case studies all live. Please do register for future events, with the next one on Thursday. Thank you so much for joining us, everyone. I've really enjoyed today, and I hope to see you all in a couple of days' time.